Hello, I introduced the Russian company Infotech Group, and now we are going to talk about the novelties in the area of alternative autonomous energetics. Due to the internet and mass media, we are well informed about renewable power resource such as a solar battery like the one that is right behind me. However, most of the photovoltaic panels have low efficiency and the wind generators are weather conditioned and unable to be exploited in some world regions, not to speak of huge overall dimensions and spaces they occupy. That is why at present hydrocarbon fuel rates first in the world due to the drawbacks of both photovoltaic and wind energetics. This diagram shows hydrocarbons percent ratio being implemented in the energetics for factual combustion with release of carbon dioxide and other harmful emissions. Promising thermonuclear energetic plants are under the process of elaboration and seem to be a far-sighted outlook. But it won't tackle an issue of a stand-alone power supply. No thermonuclear plant can be installed for even a single neighborhood, the more so for individual vehicles. Proceeding from local conditions, building of such kind of power plants will be impossible in a number of regions. Consequently, it will be needed the current system of power transmission lines and power substations. But the major problem of the thermonuclear power plant's extension will be utilization of heat energy that will be released into the environment, aggravating the global warming challenge. We would like to introduce to you some technical solutions in the area of autonomous energetics that can be implemented in short time. Who doesn't enjoy sunbathing on the beach and swimming in the warm sea? Who hasn't heard about violent storms? This is all about the solar energy. But how can this energy be converted into the electricity? The scientists and specialists are working hard over this problem, making attempts to match up various semiconducting materials. They set up collecting lenses for enhanced efficiency of solar energy converting. But still, even such a costly material as gallium arsenide cannot make revolution in converting of electromagnetic energy into electricity. After all, the Earth received within the period of 3 days as much of solar energy as it contains in all the developed fossil fuel resources. So how can we find such a semiconductor which could provide us with electricity of high efficiency in all weather conditions? And maybe we should not seek for it and go another way, which was suggested by the nature itself? On the 23rd of April 2014, there was registered in Russia the invention of polymeric photovoltaic module and the method of its manufacturing. The key point of this invention consists in the employ of cheap conductive polymer polyaniline doped with different additives. In place of expensive semiconductor materials, and a liquid electrolyte was used for a wide range of the sun rays absorption that is like ocean water, practically absorbs all the energy of the sun rays and converts it into electricity. The experts may immediately have questions. How do you have the sun rays in infrared spectrum range converted into the electricity which will heat your electrolyte in the closed space? The electrolyte will also be heated by high-value currents that will naturally appear in the course of photochemical reactions. These challenges were solved in this photovoltaic panel. You can see a principal design of a photovoltaic panel from a side view, or the electromagnetic radiation is marked by the arrows. It falls upon a quartz glass that has a thin layer of tin oxide on the inner side, which in its turn is electrochemically coated with a subtle layer of conductive polymer doped with special chemical additives. This construction appeared to be an electrode. There is a counter-electrode on the other side that can be opaque and made in different materials such as a graphite, or a passive coating of any metal can be used. There is a special electrolyte between these electrodes. Sun rays, when penetrating through quartz glass, reversibly react either with conductive polymer or with electrolyte itself, providing difference of potential between two electrodes, and if any load is applied, the current starts to run through the circuit. Actually, it is the first counter of our photovoltaic panel. We have already mentioned that part of electromagnetic radiation in the infrared spectrum range will be simply heating electrolyte without causing any reactions. Moreover, the pressure starts to increase under the heating impact on the closed space, and the panel can be destroyed. To avoid this, metallic heat exchangers are mounted on the other side of an opaque electrode. They dissipate internal heat of photovoltaic panel into the outer space, but with purpose to utilize this heat difference and to obtain additional electric power, we installed effective polymeric thermoelectric generators to convert dissipating heat from the electrolyte into electricity. Thereby, our photovoltaic panel has two separate electric circuits. Summarizing both powers, we obtain that efficiency of this photovoltaic panel amounts to 90%, even under low illumination. A comparative diagram is seen on the screen that shows the efficiency of solar energy converting according to intensity of radiation in watt square meters. It shows that the effectiveness of photovoltaic panels made of the base of silicon is lower than 20%. It should be stated that such panels reach 98% of a market share of all the photovoltaic panels manufactured today. As it was said above, the efficiency of photovoltaic panels on the base of expensive gallium arsenide is almost double higher than those of silicon ones. On the diagram, they are highlighted by a pink color, and their efficiency exceeds 40%, although due to a high cost, they are not widely used. The figures of our photovoltaic panels are marked by a blue color. Details of this invention can be found in the text of the Russian Federation patent number 2519937. International publication number is WO2015/178794. Now let's discuss a direct heat energy converting into the electric one. As mentioned above, artificially created objects effective nowadays like automobile, plant, nuclear and thermal power stations, boiler house and others emit a great deal of unutilized heat energy either into the atmosphere or into the water that has a warming effect on our planet. How can we prevent the emission of this energy as well as the benefit from it? At the present day, it is known about thermoelectric semiconducting converters based on Seebeck effect discovered in 1821. It deals with an electromotive force in a closed circuit of two different materials under the condition that the parts of their junctions are kept under different temperatures. The effect is consequent to depends of the energy of free electrons or holes from temperature. Nevertheless, the efficiency of such converters at present days does not exceed 3%, and furthermore, it must be kept 100 degrees centigrade difference to provide this efficiency. It is clear that these shortages set limits on employing of such devices in converting of heat energy. In the 8th of June 2014, Russian Federation patent way of thermoelectric generator producing was registered. International publication number is WO2015/178795. Seebeck effect is the base of the invention, but instead of expensive semiconductive materials, the films of doped conductive polymers was used. At the screen, you can see a principal scheme of the generator. When temperature difference is made between metallic plate 1 and the electrodes 5 and 6 potentials, difference is occurred. In case to set up electric load 7 between electrodes 5 and 6, as it's seen in the picture, the electric current will flow in the circuit. Application of modified conductive polymer allows not only to reduce the producing cost and get away from expensive semiconductive materials, but to increase efficiency of converting almost to 50% and also to decrease temperature difference to some centigrade degrees that made it possible to convert low potential heat energy even under the small temperature difference. Let's see what it looks like in practice. In front of you there is a device owing to which I am going to produce electric current to make a ventilator rotate using the warmth of my hand. You witness that the ventilator begins to rotate. The warmth of my hand is being transmitted to the table by means of polymer thermoelectric generators. Consequently, the work is being done and electric current is generated. Now let's try to modify experimental conditions and put onto a working surface some ice cubes. It is commonly known that melting point of ice is 0 degrees centigrade. Take note that the ventilator is slowing down its rotation and stops and gradually starts to rotate in the reverse direction. This signifies that the direction of the current has been changed. It has happened as heat energy is now being transferred from the table to the ice. The question may arise, what should we do in the case if there are no conditions to provide even small temperature difference? Everybody knows about existence of heat pumps. Actually, there are contrary refrigerators which take low potential heat from the environment and transfer it to the other place with simultaneous concentration. To make it clear, one can touch backside of home refrigerator where a heat exchanger is situated and it feels warm. Samples of low potential heat converters were made on the same principle with difference in converting of concentrated heat energy into electricity. Here you can see a number of devices in which electric power is produced by converting of heat from the environment. In ventilator and glass with backlight, it is realized directly, while in devices with high power consumption, such as cordless screwdriver, accumulative principle is used. In other words, energy being converted from the heat into electricity is accumulated in batteries and it's spent as needed. Thus, it is possible to make devices which do not spend electric power immediately, but accumulate it in batteries when it is located in your room and you do not need to charge it from power outlet. It can be such cordless devices as vacuum cleaner, teeth brush, different toys, flashlights and other items. In conclusion, it is worth saying that exploding of solar and heat energy from the environment makes it possible to develop and then produce autonomous power sources with needed power for different devices. The more sun and heat energy we have, the more effectively presented devices can be made use of. It is a pity, of course, that these devices would be difficult to explode in cold places of our planet, as polar regions, for example. Super powerful polar energy. But we will talk about it next time.